Hi guys, this is me again. My name is Joseph Ejike Oji. If you have been listening to my previous lectures, I'm very sure that by now you are having a good time. Okay? I hope you are. Today, I'm gonna teach you a new topic. Remember, we are still in the topic of probability. Today I'm going to teach you how to use three diagrams to calculate the probabilities of events. All right, let's start. A tree diagram simply means, a visual way of showing the outcomes of any type of probability experiment. So because of that, we can also use it to calculate the probability of events, because it can show us the possible outcomes and also the entire sample space. Let's see how this works. Look at this example here. It says a probability experiment consists of tossing a coin and spinning the spinner. Look at the spinner right here shown. When you look at this spinner, you see that it has a unique characteristics. 1, 2, 3, 4, 5. Okay? Actually 1, 2, 3, 4. Then it goes from 5, 6, 7, 8. So this is a spinner. You can spin it, and then any number of your interest can come up. The spinner is equally likely to land on each number. That is, it can land on this. See the arrow for the spinner. Use a tree diagram to find the probability of tossing a tail and spinning an odd number. So tossing a tail in a coin, that's what it means, and also spinning an odd number. In this spinner, you already know that the odd numbers here are 1, 5, 3, okay, and 7. See? So let's answer this question using the tree diagram. Got the next section. You will see the tree diagram showing these events. Okay, and this is one way of presenting a tree diagram. In my next question, I will show you a different way of presenting a tree diagram. They are all the same thing, basically. So you choose the one that you prefer, or the one that you are more comfortable with. So remember, when you toss a coin, you get a head and a tail. And for that spinner that we have over here, you see that this spinner goes from 1, 2, 3, 4, 5, 6, 7, 8. So it goes from 1 to 8. So starting from that head, you mark you make 8 boxes. 1, 2, 3, 4, 5, 6, 7, 8. Then on the side of the tail, you also make 8 boxes containing 1, 2, 3, 4, 5. Okay? Now here, starting from the head, you have the outcome here will be head and 1. See? Head 1. For the second outcome, you have head and 2. For the third outcome, you have head and 3. You can see all of them written here. For the fourth outcome, you have head and 4, head and 5, head and 6, head and 7, head and 8. That means head showing up and the spinner spinning 1, for example here, or head showing up and the spinner reading 2. That means head and 2. The same thing on this side, tail and 1. tail and 2, tail and 3, tail and 4, tail and 5, tail and 6, tail and 7, tail and 8. See? So if you look at this, it looks like a tree. That's why we call it a tree diagram. Now we are looking for the probability of tossing a tail. I mean, you say find the of tossing a tail and spinning an odd number. Okay? All this, that means we are not interested in the head section because it wasn't asking us about head. It is asking us about tail. So we concentrate on this tail section. Okay? So we are looking for the probability of getting a tail and an odd number. These are the odd numbers here. 1, 3, 5, and 7. And these are the tail. So tail and 1, tail and 2, tail and 3 and 5, and tail and 7. These are the possible outcome of getting a tail and an odd number. And there are 4 of them. 1, 2, 3, 4. So that the probability of tossing a tail and spinning an odd number becomes 4 over 16. Because there are 4 outcomes. 1, 2, 3, 4. Out of 16. How do we get 16? If you count all of this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. See? So you're going to be 4 outcomes out of the possible 16, which you can put in a calculator. In this form, I have my calculator here. As usual, I have to clear it. I got 4. Okay? 4 divided by 16. That will give me 0.25, 0.25. And that's what we have here, 0.25. You can also call it 25% chance of getting a tail and an odd number. That makes sense? I'm sure it does. Now, you know that we can also try another example, and then that example can be a tree diagram example as well, but with a different method of drawing the diagram. So let us try it again. Let's see what happens. Okay. I'm thinking of okay. Let's see. Look at the second question. It says, determine the probability that at least one head appears in 2 tosses of a fair coin. Actually, let me make a correction here. A fair coin. Okay? Yep, that's good. 2 tosses of a fair coin. We normally say fair because the coin, if the coin is bent, maybe something caused the coin to bend, it won't be fair anymore, because if it bends, it might make it more possible for one side to occur all the time. So the coin has to be straight like a normal coin, no bending. The other side cannot be washed out more than the other side, and so on and so forth. So he said, find the probability that at least one head appears in a 2 tosses of a fair coin. So let's solve this. First of all, let's remember that H stands for head and T stands for tail. Now, we are going to draw the tree diagram that will show all the possible outcomes. Call it sample space. So like I said, I'm going to explain to you how to draw it. Okay? So let's see. We said 2 tosses of a fair coin. The first toss, this is the first toss right here. It's the first toss. I'm going to insert the diagram here. The first toss can be head showing up, or a tail showing up. Okay? And from the second toss, this is the second toss right here. So that means it can be a head showing up, okay, or a tail showing up. The same thing applies on this side, a head or a tail. Head showing up or a tail showing up. So with this, we can get our possible outcome. It can be head showing up on the first toss, head showing on the second toss. So that's gonna give us what we called as outcome as two heads. Or it can be head showing up and then tail showing up. So head showing up on the first toss, on the second toss, tail might show up. That gives us the outcome of head and tail, head, tail. Or it can be, when we toss it, the first time tail might show up, then the second toss head might show up, giving us an outcome of tail, head. Or it might be tail showing up on the first toss and tail showing up on the second toss, giving us this outcome of tail, tail. So these are the possible outcomes: head, 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 tail, tail, head, tail, tail. This gives us 4 possible outcomes. Now the question was asking us that at least one head appears. Of all this outcome, at least one head is here. This one have at least one head. This one have at least one head. This one have at least one head. At least one head means one head or more. So there are 3 outcomes that have at least one head, which I put in a brace bracket like this, so that the probability of at least one head becomes 3 out of 4 possibilities. Because remember, there are 4 possibilities: 1, 2, 3, 4. So it's gonna be 3 outcomes, which is this, this, and this, out of 4, which give us 0.75 or 75%. I hope this makes sense. So this shows you how we can use 3 diagrams for finding the probability of events. Okay? And this concludes our lecture. But before we go, remember to subscribe to my channel so that you will receive notifications each time I have a new lecture. Thank you for listening and have a nice Sunday. Bye-bye.